the other topic. So, but essentially, when you talk about technology, that sometimes you have got power plants of the CO2, right? So, lots of CO2. CO2 is not a problem for you. CO2 is a really not a problem for you, but you have got plenty. So, sometimes CO2 can be injected into ash to make carbonates. You know that one? That's what is called mineral carbonate. So, then in that case, you can make some dolomite type product, okay? Potential. So, you can again utilization of your waste, two waste streams, CO2 and ash, make a usable product. You can reduce the CO2 emission. That's one.
So what we make with
So you make kind of dolomite, carbonate, carbonate, mineral carbonate, say magnesium carbonate, calcium carbonate, things like that, right? And CO2 is also stuck there, right? That's one technology. Another technology, lot of people are trialing CO2 you get and you put in an aluminum pond. I'm not sure, is there anyone in India you are familiar with or anyone is me? You know algae. So there are various ways to produce algae, and then it's CO2. So you take CO2, put in algae pond, make biomass, and use that biomass because algae, once you dewater it, it becomes dry biomass and it has got number of products you can make. Particularly most people interested with what is called omega-3. Many algae has got omega-3 is a high value product, you can get a small amount. But essentially biodiesel type product, or nowadays if you have even hydrogen you can make. So but these are all kind of, I would say laboratory studies. It's more than that. There are big algae ponds in the Middle East. You have to have investment, you have to genuine kind of, I would say, intention to reduce CO2. Then these are the things can be looked at, but obviously with land you need to have a proof of technology, what type of algae you can grow in a system, how much CO2 can be actually absorbed, because when you put CO2, you have got pond, you pass it, some CO2 will go out, some CO2 will be absorbed by the plant and they will grow, okay? And you need to put some nutrients like say urea, fertilizer or something, because they are living organisms. So now again the cost, again the CO2 emission, net CO2 emission. And that's why I said technical mix and LCA, that means required. So these are the technologies I know that power plants are using and thinking about. Using waste heat. If you have waste heat, then you can pose it. Trizen, people are talking about, isn't it? Have you heard of trizen? So heating, cooling, and also power. That's why you can use CO2 emission. So there are many ways obviously, but there has to be cost effective. And what is the net CO2 footprint, and unless you determine that properly, LC is a good technique, but there is no other way I know better than LCA can determine this, not only CO2 but other footprints. If somebody comes up with better technology and better methodology you are out of, let me know, I am happy to know. Okay? Any other question or comment? How we are going? Alright, so now the last topic today, I think maybe we will finish early if required, is that okay? Because we are not doing any break, so finish that.
5 minutes.
5 minutes break. Okay, so at the end of the day, as I said, I want to give you the flavor of how to do LCA, what it's all about. It doesn't matter what job you do, it's a little bit, I'm sure this is not familiar kind of area, so but it's a bit of technical process, and I'm not going really deep in because people are doing LCA experts in years to I don't expect that, but it's more simple calculation or simple evaluation if you can do or someone down under you, at least you know. That's the way I see. So I think we spoke about that this module. I've seen that it says that LCA of hydrogen production. So one of the area, obviously we are saying that hydrogen is one of the solutions obviously. So that's maybe power industry, maybe steel industry, maybe other industrial processes. So how that fit, actually some of the slides I've already used and shown you, but we didn't those information because I went very quickly and we can go deep into that. And then, but I will show you one slide, and to prepare the slide, we brought up back in tool, and I'm not going to say that tool because that's not a job, that's a kind of we have done over years and etc. But if you ask more question, I can say, but I can show you the result how to do that. But that, for example, what hydrogen application is steel making, what is the cost, what is the CO2 reduction, etc. So that I told you that couple of our students and other works we are doing based on that kind of activity we develop. So I showed you this diagram. You can remember that when you get a system, you need water, you need hydrogen, and that's why we are at. Maybe you can oxygen as a byproduct, ammonia can be used in a car or many other applications. And to do the LCA, to do the techno-economics, you need to understand small every system you need to develop more than that. So that's what I spoke about already, 70% electricity, 20% electrolyzer cost, and you can calculate this, you can model that to get the $2 per kilogram, what the cost should be, the electricity cost, the cost of the electrolyzer. Okay, so at the moment, the electricity cost we are talking about, what is that in India, what's the, anyone tell me industrial electricity price, dollar per megawatt?
6 rupees per kilowatt hour.
What is it?
6 rupees per kilowatt hour.
$9
$9?
around
For us, for user. In dollar,
or 10 cents.
10 cents
10
per
cents.
kilowatt hour, so $100 per megawatt hour.
Yes.
$100 per megawatt hour.
Per
That's
megawatt.
industrial rate.
yes.
Industrial rate. Quite expensive, isn't it? Is that what's the production cost in the area?
Like 5 cents per kilowatt hour.
So half kind of that's qualified power plant. Right?
Yes.
Okay. So to get hydrogen below $2, you need $15 per megawatt hour, around that range, 15 to 30. Okay. So that means at the moment you are talking 50. That's the production cost. So somebody has to use it. So one option is that somebody, because you are producing it, you are selling to someone, right? So if someone make a hydrogen plant and he has got his own power plant, he's not selling it, he's coming directly, maybe $50 you are talking about, right? And if you can drop down a bit more, possible, right? Possibility. But if you sell someone, I'm a hydrogen plant owner, you are a power plant owner, I buy from you, you make some money, you 50 to 100, doesn't work. Make sense? Is that make sense? So that's one way. The other option is that reduce the electrolyzer cost. At the moment is about $1,000 per kilowatt or $1 billion per megawatt. That has to be maybe $200. So 200,000 per megawatt system. If that is the case, then you can ask. So that if you have a model like this, then you can develop lots of scenarios and you can answer that question. Where exactly we can start? What's the configuration? And obviously offtake RGB of the hydrogen. Does that make I have explained well? Clear? Any question? Yes. So basically electricity, so the 70% cost is the electricity. 30% is the electrolyzer. It doesn't matter. So that will be 50. So now to get so if you want to produce hydrogen below $2 per kilogram, you need to have cheap electricity and cheap electrolyzer. So they are saying that it's $100 per megawatt hour at the moment. In the market, if you buy electricity, but production cost is $50 per megawatt hour. So still it is expensive for, so $50 maybe you might get somewhere here. Okay, that's what we are now. So now if you have a power plant, you produce electricity at $30 per megawatt hour. What the argument is saying. You own the hydrogen plant, instead of selling that electricity to someone, you produce hydrogen, you become the hydrogen producer, owning the electricity plant, and if you have a cheaper electrolyzer, at the moment it is 1,000, you reduce to 200 because people are working on new technologies, then it becomes mainstream economy. It becomes competitive with petrol, it becomes maybe even cheaper than many other things. You have also zero emission under control. Does that make sense now? Does that answer your question? Anyone else, any confusion or any clarity?
But we are using steel, but electricity from power plant only.
Yeah, but power plant you own. The hydrogen plant owner owns the power plant. That's what I meant.
The CO2 emission is not reduced, no? CO2 emission is there.
The CO2, but I'm talking about say
Cost is reduced. Cost is reduced.
Yeah, but if you have say coal-fired power plant, then if you capture CO2, okay, which will add a bit of cost probably, that called blue hydrogen. So blue hydrogen at the moment, hydrogen is grey, which comes from natural gas, steam, methane, before. If you go for coal-fired power plant, you capture CO2, okay, or even you can but it will be kind of blue hydrogen because no CO2 is captured to control. And initially maybe a country, think about if you have a lot of resources, coal and etc., maybe go for blue hydrogen. So it initially blue hydrogen and later probably green hydrogen come down. So blue hydrogen production come down, green hydrogen goes more, maybe 50 years time, mainstream economy becomes mainstream economy. But these are all hypothetical. I'm saying, is it real? Will it be? Will it be actually? It may be. I mean, it's because, as I said, a lot of things we do not predict changes. UK has completely closed coal-fired power station. They are going others. Many other countries, I think Australia is reducing. There are other reasons. Who supplies coal-fired power stations? Various companies, right? Babcock and Town and who else? Intersheet and who makes manufacturers, Siemens, right? So those companies are slowly reducing investment on those technologies. Even if you want to buy coal-fired power plants, unless you develop your own network of servicing, etc., nobody is going to give it. Bank will not give loan. So what do you do then? What are the choices you have got? You get electricity, right? So then maybe those things, the current government gives incentive. That's how a new industry develops. It's completely new industry. There is no hydrogen power plant in the world, large scale. You can think about it. There is now currently, but Mitsubishi and some other companies are developing hydrogen combustion system. So it's a hydrogen turbine. So essentially, instead of gas turbine, so it's more coal. Maybe it's a different story. Coal is completely different beast. Then CH4, a lot of gas plants. Gas to hydrogen transformation is relatively less challenging and easier. And even with cars, same thing. One is the fuel cell operated hydrogen car. Another is we have got so much advancement in ICE, internal combustion engine. Toyota has there so many plants. So they make, I don't know, few millions of car ICE compared to whole world where there are 30,000 hydrogen cars. So if you can combust hydrogen and do the same thing and you get water out of the system, that may be the mainstream technology. So these are things new, maybe not now real, but looks real. But the main issue is that you need to produce hydrogen at cost. You will have scale. All the petrol station has to be converted to hydrogen station. Then it's possible. It's a chicken and egg problem, like new industry, any new industry. But given, some people say, no, I'm not convinced. Maybe not. There are reasons not to be convinced. But if you look at the solar plant, solar PV, it's making so much inroads, then maybe it is possible. Okay?
What is the capex cost for a, say, 100 megawatt hydrogen?
100 megawatts, 100 million, let's say.
100 million.
That's now, but over the years that drastically with learning car, with wide scale adoption of technologies drastically reducing. And people predict that 2050 that will be $100 per megawatt or 100,000 per megawatt, what you said, I said that. Or so what was 100 million or 10 million, because 10 times reduction possible. And I can tell you that our scientists 3 years ago we were working on electrolyzer technology, because electrolyzer is a lot of precious metal or a specialty metal is used as a catalyst. If you can have lower metal catalyst, so we already unloaded how much coating is required. So we have, it's a kind of nano scale, very small microgram per meter square in foot per centimeter square. So we reduce that by half. It's still the same performance. So that means we have half the price essentially, right? Although the catalyst is not important, complete part of the cost. There are balance of the plant, there are other things, but overall, and there are hundreds of groups are working, scientists are working to develop new technologies. So I feel like if we can, our molecular scientists can make it, then other people probably having some solutions. So if technology cost reduces, that's another way to reduce the cost. Okay? Efficiency, that's another one. Longevity, that's another one. So these are the things slowly people who know about suddenly becomes reality. So that story interesting because of the electricity cost. Can somebody produce low cost electricity? Some countries have got cheaper electricity, and not only that, as I said, your asset you maintain 400 gigawatt, you are running maybe 200 or something up or 300, at least 100 gigawatt sitting there somewhere. So how do we extract that value? That's another way to reduce the CO2. So that's I showed you that the average cost or the cost, right? That you can remember with the tax big compared to the renewables, you remember that. So I'm sort of repeating that, but I guess that to reinforce that that's the same with CO2, but it's one scenario. We can have multiple scenarios like that. And more instantaneous. This is for data analytics. So data analytics has to be brought into so that you have lots of data you can analyze and make a decision. Now this is the one I spent quite a while, and this is very complex slide, and you can explain and you will spend. This is the one. Sorry?
Then you can take it next because already snacks
Is there?
is there.
So
Actually, our earlier program was 30 to 30. That's for the snacks.
So do you think after finishing this we can have snacks? That's another one. Is it? I mean, let's finish that. What do you think? So you see. So look at that many what do you call axis, and I try to use behind that lots of calculation models, lots of models sitting. They're spitting out the information, and I'm trying to plot it here. So let's look at that. So this is the delivered hydrogen price to your plant. US dollar per kilogram. So let's look at that basis. So what I'm using $0 to so free hydrogen to $12 per kilogram. Hydrogen. Somebody, I don't need to know. You have plant, you have electrolyzer, you have electricity. I just want hydrogen at a delivered cost. Clear? This one? So this axis is clear. Let's look at the other y-axis. So this is the production cost of DRI. So that would pellets plus the air. So how many, can you hands up how many steel maker here? Steel plants people? Well, fairly good. And how many power plants people here? Power plants. Okay, so power plants, sir, that's your kind of related with hydrogen production. And steel people, that's the related with DRI production. Make sense?
Yes.
Okay. And what's the DRI? I'm starting with $300 to $800 per ton of steel. Okay. So because I have steel, because I have pellets plus air, isn't it? That's the steel, right? Makes sense? Now to do that one, I have, as I said, I have got steel making technical units, I've got hydrogen technical units behind sitting there, and that feeds in those kind of information. What is this one? Kilograms CO2 per ton of steel. Okay. So we have. So these are the. I think even the chief executive boardroom, many experts do not appreciate this diagram. Do you understand where I am coming from? It's quite complex diagram, isn't it? So three things we are playing with: kilogram CO2 per ton of steel. So you need to be an LCA expert. To calculate that, you need to have a technical expert. Okay. And obviously hydrogen expert plus. So three expertise put together, and you calculate this number. Clear? Okay, now the scenario is that. So I'm saying. So first one, let's look at that. Green hydrogen plus green electricity and CO2 only for other minor items. So green hydrogen, currently less, now CO2 almost, right? So if I say that one, the CO2 will be nothing. Still CO2 will be nil because your so only small, actually it's not nothing, it's maybe very small, negligible that comes from running the plant, etc. etc. It's not because you know that plant, heat, everything is given by hydrogen. Okay? So now see, at least this is how we are thinking. So green electricity plus green electricity coming to the plant, steel plant, here I plant here, green electricity, green hydrogen. That's the scenario. And you get $300 per ton of, and that's delivered hydrogen. I'm saying, and you can make it the delivered hydrogen depending on, that's one scenario. Second was green hydrogen plus electricity is from conventional black coal. So hydrogen is conventional black coal. So you get 200 kilograms CO2 per ton of steel, and the price is around, say, sort of 370 or 60 mark or something like that. I don't know. So that's the line, okay? Then you have got green hydrogen at 2.5 kilograms CO2 per kilogram hydrogen, but you are running your plant at green electricity. That's the scenario we're talking about, $400 per ton. So I think that green hydrogen you can produce lots, and if you have a green electricity, you produce your steel at $400 per ton, it's not bad number, isn't it?
So you are using both power plant and green electricity to produce
So this gets green electricity, yes, so coming from human electricity, we assume that green is completely nice, clean, and we have got plenty of that, and then we make hydrogen, we run the plant, electricity plant, power, DRI plant plus air plant, that's the scenario. Okay, and then if you increase the price, and you can probably see that one, then what is this one? This one is again green hydrogen at that footprint of hydrogen, 2.5 kilograms CO2 per kilogram hydrogen, plus black hole electricity goes up a little bit. Then certification threshold, that's called certification threshold at 4 kilograms CO2 per kilogram hydrogen. Because if you look at it globally, whoever producing hydrogen, if you produce below 4 kilograms of CO2 per kilogram hydrogen, you can claim it is clean. That's the global certification body is saying. Actually, some countries are 3.54, some countries are saying 3, some countries are including infrastructure like electrolyzer, etc. But generally, below 4 you can claim your hydrogen is relatively clean. Okay, so that's one scenario. And I'm saying certification, if you certified hydrogen plus green electricity, $500 per ton. Okay, and your CO2 footprint of steel will be 600 kilograms per ton of steel. Yes. So this line is more kind of, I would say, realistic, or maybe let's look at the last one. Gas-based hydrogen, which is current hydrogen produced. It's produced at very low cost. There are plenty of hydrogen like that. Black hole electricity. That's a conventional now what you are doing. If you want to bring hydrogen in the DRI plant, so you get $700 per ton of steel, which is not bad either, also, isn't it? And black hole electricity, but your CO2 footprint is below 1.2. Still,
as per the current scenario, we use as the electricity of thermal power plant and produce hydrogen and use in the steel plant. You are saying that?
Kind of that, but gas-based, but hydrogen comes from gas-based gas production, SMR, what is called steam methane reforming, which is current method of natural gas. You make kind of hydrogen from that source. Natural gas is the feed. Okay, not the green, not the green. Natural gas is the steam reforming. Okay, natural gas is the feed. So now, what I was saying that, so crude steel price in 2024-25, if you look at US dollar $850 to $935 per ton. That was global. You look at global market, you cannot say spot price, what is the price today? You have to look at least 5-10 years, kind of that, something like that. Is it am I right? Or it's a high end?
Bit higher. 70,000. It's around 70,000.
So 7,000 means dollar. How much is dollar?
Like 70,000 Indian rupees per ton.
But you are saying 50,000 you produce.
It's a production cost,
So,
but the
this
selling price is 60,000.
This is in euro.
It's a selling price, you can say.
So selling price sounds reasonable.
It's
No,
about
I think I'm saying production price. Or not selling price, that is selling price.
Indian production price is lower than the European.
So you know, even worst scenario, still you are 700. It's still not bad, I would say. Isn't it? So now the next scenario, gas-based SMR plus green electricity, then certified I think plus black hole electricity. Still we are talking about between $5 to say $550 per ton of steel, and you are talking about 600, 700, so 0.7 ton of CO2 per ton.
This line I'm not getting. Gas-based SMR is 2. You are making hydrogen from
So natural gas.
natural gas.
It's like a fertilizer plant, anywhere, ammonia plant, you go there. So gas and ethanol plant, same story. So you go gas and steam mixed together, okay? And then crack into CO2 plus hydrogen, you separate, you get your hydrogen, you get CO2.
So your energy is you are getting from the gas.
No, sometimes you have to add additional energy, but you get, it's a gas, gas kind of, what do they call, gas kind of, not necessarily pyrolysis essentially. So it's a methane reforming from
It's a reforming process, I get that. But to reform that water molecule,
you need energy.
what energy are you using?
But not, even if you use gas-based power, even on the plant, gas power, usually most of the SMR plant has gas-fired power plant, or it comes from the grid, doesn't matter really. Not really renewable we are talking about, and that's the that footprint of CO2 is 12 kilograms CO2 per kilogram hydrogen. Okay? So 12 is that one. If you took your green electricity, I showed you that 45. Okay? That goes that one of the because you can make multiple hydrogen. So majority of the world hydrogen is currently produced from natural gas using SMR. And if you go to a full proof of fertilizer plant or any fertilizer plant, you will see that one. Ethanol plant, you will see that one. So that is gas, little bit electricity, but mostly natural gas is the feed. Okay, and that is 12 kilograms CO2 per kilogram hydrogen, and that's why certified system they said you have to reduce 60% or 70% of that energy because below 4, then you can claim. So, but that's called gray hydrogen. It's the worst hydrogen in the sense. But if you capture CO2, because we are separating gas, natural gas CO2, you capture this, you use it or store it, then that becomes called blue hydrogen, and that is below 4. Even it is gas based, but it's still blue 4 because you are capturing, right? So you can have blue hydrogen or green hydrogen, or blue or gray. So gray is the worst, then maybe black, gray and brown, which is black coal. You can have, instead of natural gas, you can use black coal. You can use brown coal. So ultimately the product is hydrogen. So gray, black, brown, all three have got substantial CO2. Okay? If you can capture it, then that's called blue hydrogen because already you are capturing CO2 and become low CO2 hydrogen. Then final thing is that we get green. Ultimately the green hydrogen. So which is low CO2, almost real CO2, but that takes time. We're not. So say gray hydrogen, black hydrogen, or brown hydrogen we talk about is maybe $1.5 per kilogram hydrogen. Already cheap, but no CO2 advantage. If you say blue hydrogen, at cost it may be, I think it may be $2, maybe something like that. But green hydrogen is still expensive. I think sorry, I think nobody is hearing. Can you hear now? I think I'm sorry, I didn't put that on. Anyway, so now I used another thing. Hydrogen is 15% of the total cost. This is a scenario, and at 58 kilogram hydrogen per kilogram. That's the amount generally people use. Okay? So you see coal, how much coal per year? If you compare it, I told you that coal hydrogen has got higher density energy than compared to coal, right? So those you get advantage. On the other hand, there are disadvantages in terms of gas and energy. It's more energy density than natural gas. You know natural gas energy density. So it's about 55 megajoule per kilogram, something like that, or 55 gigajoule per ton. Yeah. So hydrogen is more than double, right? So that's not. So that at that scenario, so I have fixed this one, but I can generate multiple graphs like that because I have the model still here. So to develop that model, that needs intellectual input, that needs technical input, that needs expertise, and that's not a 2-hour job and you come in training and you learn. Not like that. You have to invest. It's a project. It's maybe a $200,000 project. So that's what I'm doing. So this sort of LCA course, people go. I was telling that it costs $5,000. If you go to MIT, there's LCA course, and I've seen that course. I've seen other people do that one. It's very light and not a lot of people hands-on LCA experience. So it's quite expensive. I used to run this course during COVID-19 free online. Because my students and etc. training so many people. There was nothing to do that time. A lot of people didn't do, so I did online training for various countries internationally. So that's the LCA. How it is useful, this axis, how technical useful this axis, how hydrogen expertise is useful. So these all together, analyzing that, I can claim maybe not many expertise, not this type of expertise, maybe I'm the only one. So I'm not saying that, there are other people, but it needs multiple expertise. Okay?
I'm not with the full graph picture. You're the x-axis, you're not using the cost of the hydrogen.
So x-axis, again, x-axis is the, so it's a pick a number. This is the $6. Now, there is certain things, I know where you're coming from, it's not relational kind of thing. So I put a number just to explain easy way that says a $6 hydrogen price, okay? If you want to $6 hydrogen price and that, say that kind of scenario, you may have either $500 per ton of steel and your CO2 will be around 700, 600 something and whatever you calculate.
And that $6 hydrogen bag we will get from that 4 kg CO2
Below 4
per
kilo, certified hydrogen. We call it certified hydrogen. Certified hydrogen plus black coal electricity you have got grid, connect with your power plant or DRI plant. DRI plant draws current from the grid. That's the scenario. 500 watts.
take one scenario in at present we don't have the green energy. Green electricity we don't have, suppose. We only have the thermal energy.
So that's what it is.
Exactly.
That's black electricity.
Top one.
The top one is the black electricity. Yes, that's right. But hydrogen from gas based.
No, I want to produce the hydrogen from that coal based plant electricity.
Coal gas based not too dissimilar. It's not big difference.
Not big difference.
Not big difference. Because coal is gasified and hydrogen produced. But if you say coal fired power plant, you use.
Yes, I want to coal fired power plant.
I don't know because
that will be
if you go back to here, you can calculate here.
And that scenario cannot be considered.
You see that
It should not be considered, you are saying.
you should, because you have got 45 kilograms CO2 per kilogram hydrogen. So that's, and then what I am talking about natural gas SMR, I think this is the one probably. This is the one. This is the gas SMR. Because that's the majority of hydrogen is produced like that, and that's well established technology. Hundreds of plants, thousands of plants in the world. There are expertise. So it's even gasified coal, that technology exists. 20% of ammonia Chinese produce from black coal. Brown coal, even brown coal is good one to make hydrogen. So it's not a problem. Problem is handling CO2. So you have to capture CO2 to make blue hydrogen. If you don't have the carbon emission reduction drive, it doesn't matter really. Everything is cheap. But if you have that imposition, and that is imposition, we have no choice. We have to use CO2, right? And that's why we're doing it. Why I'm here. There was no point if there was no CO2 driver. Nobody would bother. Nobody would value me. And now everybody values me because I have that expertise. I know exactly how to calculate CO2. Does that make sense now? Is there any other question or comment about the diagram? So ultimately we need to move to number one. So if you want to use, but another point I can make. Power, power is relatively cheap product, I would say. For if a country is producing lots of hydrogen, we need to think about what is the best technology. So you can rank, okay, hydrogen cost or everything you are doing, and then at price hydrogen is delivered, and you make power, you make chemical, you make steel, you make electrification, you rank them. Power would be the lowest. I think hydrogen should not be used for power production. It should be used for steel, chemicals, green methanol, green fertilizer, green. That's where the best value is. But that's why people are thinking now that those people have big chemical industry, Middle East and other places, and that's why I said money there, because there's a high value for that. With power, it's hard to make that money.
So in the UK, as they have shut down all the boilers for the power plant, so what is the energy source? Wind or solar only?
Plenty of wind.
Wind and solar only?
Solar wind, but I think North Sea has got a lot of offshore wind. And also gas.
Gas turbines.
But another thing.
Okay, they have the
I have one question.
Russian gas. They have the Russian gas. That's why.
Okay.
Since you have almost most of the countries, which country is nearest to produce green steel right now?
Green steel.
Yes.
Which those countries which has got like Middle East maybe, I think because they have got plenty
No,
of renewables.
that is theoretical. I mean, where actual work is going on right now.
Actual work, if you say, I think Australia is seriously thinking like say Liberty Steel, that's an example I gave.
So they will completely obsolete the blast furnace and go for this DRI.
They are EAF or DRI and EAF, and that's a different scenario because they're magnetite resource. And
They don't have so much blast furnace. They each are
Actually, the biggest blast
Phasing
furnace
out is easy. Phasing out is easy.
that is the easy thing to Europe and USA, that the blast furnace size is quite smaller as compared to
and also
Japan,
become
South
more
Korea. Yeah.
then in replacement maybe they are already lifetime quite big.
but that is actually Australia's very big advantage. But in case of India, what a lot of blast
So
furnaces
one
are there.
thing,
We
In India, we have the best opportunities, the syngas injection in the stack.
Yes,
But that's a limitation. That will be around 10 to at max 20 kg per ton of water. Like the certain age. That is 10 to 20 kg. That's my presumption. That is 10 to 20 kg per ton of water. The current fuel rate operation is around 535 kg per ton of water. So it will be a minuscule percentage of what we are expecting.
And another thing, what about gas in India? How many dollars per
Not that.
How many dollars per kilo? You pay $15 per kilo or $20 per
So you
kilo?
are suggesting the steam reforming process for producing.
Say you buy gas.
Yeah.
What is the gas price?
That's a process.
The last one is we can do one thing. If in case of that is methane plus H2O, we can use CO plus H2O.
Potentially, yeah.
Because blast furnace produces CO.
That's right. And then you use
That is used by our power plants
yes,
and other units. And something is flared out.
yes,
So the flaring part can be controlled to produce
more hydrogen and more power like that. So these are the mechanism, and maybe you need some investment, maybe you need to So those are another thing, easy way. I find that I don't know, some places gas is obviously up and down, right?
Yes.
Ukraine war suddenly $25 per
Yes,
kilo.
it's not a
I
reliable
think
source.
the oil injection already stopped like of the Gulf War.
Same with oil. Oil is even more precious, isn't it? Forget about oil. Oil is gone basically. We think about gas and maybe other fuel sources. But what we are saying also, another those companies have to get a small hydrogen. You can easily send to your gas station. Blend it up to 20. They say up to 20%. Forget about 20%. We have 3 projects in Australia. So we are injecting up to 5%. There will be trial, but there are again everything has got its pros and cons. And if you are stuck on certain box, you will get out of that. You say, I'm sort of like putting your head under like an ostrich kind of that. So what it's saying, we produce gas, we put in a kind of so 5% gas is fine. More than that, because hydrogen eats the steel and makes it goes to the system. So you cannot put then you have to change the infrastructure like gas pipeline, etc. That one thing. But another thing, when you deliver gas, you deliver at a certain energy content, right? And it's called OV index. I think you may have heard of some of the chemical engineers. So there is a certain number, and you meet that specification. If you mix hydrogen, because hydrogen has got a high energy density, but volume is low. So the same mix at a ratio, what's the ideal mix? So those questions you answer, but generally 5% no issues. Because CH4 has some hydrogen.
I think this blast furnace, there is stoves are there, right? So we preheat the air and we inject in the blast furnace. So if we use hydrogen as one of the fuels, but the burner design has to be changed.
Generate a little bit, but again, if you are going for ammonia, I would
So
say
actually we tried CBM once, cold-based methane.
methane gas also. So if you do that sort of blending, I would say hydrogen is better go blended with gas. You can have a DRI, etc. That may at least reduce a bit. Do that calculation, see that cost without changing the infrastructure, potentially possible. To go beyond that, we are saying the burner system has to be volumetric. I have got 2 projects on that. One is doing a CFD model, computational fluid dynamics model, to do that various blended ratio, 100% versus 0, or mix 0% hydrogen and then 10%, 20%, 30%. What sort of consequences of that? So, but I find nowadays, even India is producing a lot of engineers, China is producing a lot of engineers. Engineers has no basic understanding. I mean, that sort of thing, if you give them calculation, they will struggle. So, I don't know which world we are in now, somewhere that will be frustration, but whether they're actually studying or the curriculum change or we're not teaching properly, basic energy power calculation, lots of people. I'm not an engineer. I studied science, later I studied engineering, I learned through the system. But these are the things I think people need to be aware of. I don't know whether that what I have spoken makes sense or not. Any other comments or question about hydrogen? I said anything about hydrogen, you can ask me. What would I recommend?
Sir, I want to understand
Yes.
graph more. Actually, based on these horizontal lines, the bottommost line is most clean as I understand.
Best option.
Base.
Top one is the worst option.
Yes, and
And in between options.
yes, and the production cost for the
Best option is the lowest, yes.
Yes. And then how I will calculate the delivered hydrogen price from this graph?
How you calculate?
Yes.
Okay, so that's another matter. That's called hydrogen cost model. I can go in deep end of that if you want to, but for the moment I said, and that's the, you see that one, that costing, where is that one? That's the costing of hydrogen model. So basically it's called levelized cost. That is electricity. Hydrogen cost model is very simple. Electricity cost, if you know the electrolyzer cost, that's what is called we have a levelized concept, levelized cost. Levelized cost concept, you have idea? No. So levelized cost, say I have got a technology and I am comparing another technology. I produce a product, it's $1 per unit or rupee per unit of product. Now different technology, it's a nuclear, coal, gas, hydro, different capital costs, right? One is higher than other. How can you take into account? So you need to have that capital cost, you need to run the 20 years, and then you do that, what is called compounding, that interest calculation, etc. And then you can compare, it's called levelized cost, because we have taken into account, because nuclear power plant, it's the capital cost is very high, operating cost very low, $30,000 per year. Okay, I'm just giving a number, it's plus minus. A coal-fired power plant, 3 million ton of coal, you multiply by $100 per ton, so it's a $30 million coal, isn't it? Something like that, I don't know. So, but coal-fired power plant, you have lots of operating, your capital cost is maybe $1 million per megawatt, whereas nuclear maybe $5–10 million they're talking about, from because most of them overrun, will take a long time. So how do I compare technologies? That's the concept of levelized cost, which is takes into account of the capital investment. Does that kind of basically say that? So what it is, I'm talking just, I gave you 2 minutes option, but you need to do spreadsheet, calculation, some software can do that one. So anything we talk about levelized cost, so that you can compare apple to apple, because you're taking into account that investment cost. Okay, any other question?
It is predicted.
This is based on those. This one is predicted, but at the moment this is the cost. It will be 3 million. That's nothing. This is current one, and then the prediction. If you predict based on the cost, based on maybe power purchase, because in Australia I can see that PPA, power purchase agreement, if you have large solar wind cost, is around $70 per megawatt hour. $60–70. I've seen even less, $50.
Australian dollar.
Yeah, it is coming down. But
You are Australian dollar or US dollar?
Australian dollar.
Australian dollar.
So it was coming down even further, but COVID made trouble, because if you say you want to make 100 megawatt hour wind power, turbines and wind turbines, etc. supply, you have to wait probably 2030. Even if you want to, because the supply issue has been kind of disrupted because of COVID and other issues, it is not picking up yet. That's why the cost is not going up.
This is the conventional hydrogen.
Yes.
It is predicting that by 2030
So conventional,
blue one.
this one is it? So it's not necessarily it's there, it's the same. The other one is that conventional. Conventional is now, because it's a supply demand issue, maybe more green hydrogen will come, less demand for, that's the way. I'm not sure that they're saying that. Yeah. I mean, same is coal-fired power plant. Already in Australia, coal-fired power is expensive. Do you know why? Because you have to put renewables, you cannot run it 100%, and people already not servicing, it's becoming a problem, and lots of other issues. So many companies are out of getting out. So even new coal-fired power plant last 10 years, we don't have any invested in no new power plants coal-fired. And if you want to build one, who is going to give money? Banks are interested, etc. So it's a scenario like that. So people are getting out of that. That's a dying industry.
India is still need for thermal power industry.
Well, that depends on the country's situation. I mean, you have to supply that as but some engineers, I feel like, stuck in that old ways, black and white. I think world will not change. But you know that for a moment, that like that will come up with suddenly, oh, our industry will take this. And people are squared sometimes, or lose jobs, or lose economy, and that. But in Australia, what happened, as I said, that when the solar came, big job created by solar installers and etc. Other industries developed. So maybe that's how we manage. It's not necessarily cost. Some people say should be cost or climate change. Or maybe we pick climate change, forget about cost, or maybe we choose cost, forget about climate change. No, both. How to do both? That's a key. That's the job. That's the young people needs to think about, and we need to train those young people to do that. Okay.
The green hydrogen is the renewable energy. Same thing is
Sorry.
renewable hydrogen. That is the green hydrogen, na?
That's right.
Same thing.
Yeah, renewable hydrogen is green hydrogen, I would say. Because green means that low CO2, renewables, etc. So any other question, any ideas, there is a chance, any question about hydrogen, I said you can ask. Anyway, a lot of people, wherever we go, a lot of people do not know about that it's a new industry, etc. But if you work quite a bit of while, I know that there was a big hype and that's come down, but as I said, our government is supporting still, and I think, and obviously many countries in the Middle East, in South America, there are lots of projects going on. I'm hoping that they do some, if they come into more demonstration, we will learn. So I'm not sure. Is there any, by the way, is there any, you are aware of any demo plant or any pilot plant here in India? Other than Tata Trial?
In steel industry.
Hydrogen, I'm talking about hydrogen production, renewable hydrogen production. Is there anyone in India?
We have already built out.
Sorry,
We have already built and run. I mean, it's on the way.
Where?
Coming to DRA. In
Where?
Vijayanagar, we have 20 megawatt electrolyzer.
Where is that? Where?
Green.
But where? Which location?
In our location, we already built it.
JSW.
Is that a JSW plant?
Yes.
So what, tell us, can you share some more information? Why you picked that? What experience? What's your positive negatives? What the people thought? What's your management thought? What can you give us?
Yeah, actually, we were aware that during COP24, long back, we were aware that the climate is going to hit us like anything, and we are the largest growing company, so we must be smarter enough to cope with the challenges. So our chairman had the vision of building EAF, DRI EAF pellet plant, DRI and EAF connected to wire rod, a chain in a production line is completely dedicated for green technologies. So he has brought DRI, he has brought one pellet plant, one EAF. This has been installed in 2013. Ever since we have been finding means how to convert this into a green steel technology. We know that hydrogen can be injected. So it has been, a lot of debates happened. Mr. NKJ, our chairman, finance guy, CFO, he was always telling our chairman, don't invest in renewables, it's waste. So for a decade or so, we just wasted, and I think 2021 onwards we built solar, wind, and our consumption per day is about 830 megawatt. If you look at the calculation, 220 installed is solar, maybe 20 more, and 600 is wind, matching to 830. But you cannot claim that it's 100% renewable because there are a lot of fluctuations. So gradually, after these things came, we posted the CPP captive power plant. We tampered with the lowest technical possible limits to go down, to give boost to renewables. But recently, we had the hydrogen being discussed at large. We thought of putting up 500 megawatt hydrogen plant. Land has been acquired. The vision is that the whole of 12 million ton steel plant will consume hydrogen, whichever technology is viable we will install. Balance be converted into nitrogen, ammonia and export. So that was the concept. So it never materialized, but we finalized on 20 megawatt green electrolyzer, green hydrogen electrolyzer. It's on, commissioning has been done, and we need to inject it to DRI pipeline. Everything is ready. I think in a moment we have the hydrogen DRI running. So phase 1 is 5,000 cubic meter an hour. Phase 2 is 10,000 cubic meter an hour.
Very good story. That's really at least. So I think more you do this kind of pilot and more you learn. Because some of the things like I showed you that hourly fluctuation, these are the things more we analyze, more we learn, more the way, as you said, fluctuation is
Huge learnings. I mean, my God, mind blowing. You need to have a software. I mean, people sitting in the control room, no, they have to be always alert. 15 minutes.
What happens
15
is
minutes is the coasting time. or a ramping time. But anything if it goes wrong, then you are in blackout.
That's right.
It's very risky. And then the route, which is now green hydrogen, pellet plant 2, DRI, EAF, connected to wire rod mill. I cannot sell this as a green steel
Not
because
yet.
Indian market is not so mature. Nobody pays in premium.
Waste of money.
Just a waste of
Time.
names and fancies. We just put green steel. Yes, we achieved it.
But maybe you are the
Who will buy
first to earn that certificate of best kind of thing, isn't it?
And underlining the fact that since 2013 we have been selling the steel, not completely green steel, but at the same price as others.
Yeah, I think we not change the world, obviously. Changing the world is not easy, so always, you know.
Yeah.
So, but at least we start one step. And learn about trade and the, sorry? Yeah, sorry, any comment? That's fine, thanks, yeah. So I think that's what whenever I go, as I said, everybody thought it's a silver bullet, but we saw that there were challenges. It's not easy job, but at least some start, at least good amount of effort is going on. Hundreds of billions of dollars. I mean, I would say many countries invested, maybe Japan, Korea, Australia, US, Europe, you name it. So huge amount, at least last few years, and it's a good thing, I would say. Maybe it is not that success yet, but at least some investment made, build the capability. I don't know, 10 years ago when I started in this area, I did a race too, not convinced, but slowly learned about, and yeah, obviously there are other things, batteries, critical minerals becoming important, batteries. Another issue actually, more that is, because more I talk about, hydrogen production needs a lot of materials. I think getting $2 per kilogram is will be there. It's more where are the materials. That's even more challenging. We're talking about gigawatt scale. The whole world, the largest hydrogen plant I have is 100 megawatt in China. Some places it's been 1 megawatt, 2 megawatt. Australia says 20 megawatt. So, is it okay? Anyway, so we're just talking for that's died, not died. Anyway, seems like we have to finish. That's the signal. So, but I think that we're talking about gigawatts. It's a big challenge. Multi-gigawatt, not only gigawatt. Actually, I didn't show you that some of the people thinking about what in Australia they call sun cable. So, Northern Territory will produce, Northern Territory, remember in Australia, northern part of Australia, Singapore, 4,000 kilometers. So 4,000 kilometer distance. So we are thinking that we will have lots of power there. With high voltage DC power line, we will go to Singapore. And that will feed other parts of the, because we have got solar. Is that good one, or we make hydrogen and send hydrogen? So this sort of evaluation, tricky job. So that's some of the numbers they say $30 billion, $100 billion, and there are investors also, there are money available. So it's not necessarily end of the world, and people are really genius. They come up with all sorts of ideas and try out, sometimes they fail, sometimes they win, and that's how we go, I guess. Yeah. Any final comments for today? We can finish, right? Today? So maybe tomorrow